Dear learners, greetings from IIT Guwahati. This is the second live session of this course, Applied Thermodynamics. First live session was attended by Professor Prof. Mandal. Those in that live session, we have discussed the queries which is raised up to the mainly from the steam power systems. Was now we are in the live session. Till this point of time, I don't think we have any queries so far. But however, in the discussion forum, some of the queries were raised by the learners. I'm trying to clarify those queries in this live session. So this course is being delivered by myself, and the query which is raised from the one of the learner, which is very important, that is the question was asked that basically in the live session, one of the live session in one of the lectures, we introduced the steam tables and how those steam tables would be useful for taking the data for saturated water and superheated water vapors. So the learner wishes to know that how do you interpolate the steam table data when for the pressure and temperature when I know enthalpy of the system. So first of all, clarify this. I bring this question from the module 1, lecture number 3. And in these things, we are asked about a steady flow devices in which superheated steam enters at certain flow conditions at 1 megapascal, 400 degrees centigrade, and it leaves at the pressure 1.4 megapascal. And in these things, we are going to use the steady flow equations and try to find out the property data in the steady table. So, talking about the interpolate, we know that when the condition is at superheated steam, which is given as 1.8 megapascal and 400 degrees centigrade. So, how to refer this? So, from these things, since it is a superheated steam, we have to refer this particular book. I think the steam table data is mostly available in most of the books, but I mainly refer this. That is table number 8, A3 and A5. That is principle of engineering thermodynamics by Niranjan and Sahoo. In this book, there are tables A2, A3, A5, and those are mainly for saturated water temperature table, saturated water pressure table, and superheated water water vapors. So here the data is given as a superheated steam. So we have to refer the data from the superheated water vapor table. So giving the condition of 1.8 megapascal and 400 degrees centigrade, we can find out the data from this table. But this is just a snapshot. So how do you refer? So when I say 1.8 megapascal and 400 degrees centigrade, so you have to refer a tables that corresponds to 1.8 megapascal or closer to that. So let us assume that for the time being, we are referring 1.5 megapascal, and correspondingly we can take this temperature 300 to 320. Accordingly, we can find all the values. So this is how, when the pressure and temperature data is given, you are able to find out specific volume, internal energy, and enthalpy and energy. Now, by solving the problems using the steady flow equations, we arrive at a situation that pressure is given, which is 1.4 megapascal, and enthalpy value is more, that is 3440. So how do you do that? Here you have to, because nowhere in the table you will find pressure and enthalpy and corresponding to its temperatures. Rather, what you have to do, you have to take some interpolations. To do this, your first case should be that you have to find the table which is superheated table which is close to 1.4 megapascal. And for that, at least if the data is available for 1.5, then let us take that it we are looking at 1.5. And in that 1.5, you go along this enthalpy line, whichever value closer to this, then that you take it as a reference mark and you take a horizontal, go along that value and you arrive at the temperature value corresponding to that. For example, if I look for the data 1.5 megapascal and 326, let's say 3175. So this this gives a close to a value is 360. So roughly your value is higher than this, so you have to go for different values, which maybe you can find, and this number it will be somewhere around in this zone. So likewise, the data may not be exact, but or accurate, but it will give a closer approximations for the type of problems we are looking at. So this is how we look for the temperature data when pressure and enthalpy is given. And this is also true when you have also temperature and entropy value is given, you have to find the pressures. So all sorts of linear interpolations through your initial case, one can do that. So this problem corresponds to similar things. So that is what I brought out this particular case to define how I need to explain linear interpolation in the steam turbines. So there are many problems, solved examples in that book also. So you can refer those solved examples to find more details. Then another questions were raised regarding module 1, lecture number 4, where we discussed about the term exergy. So exergy is nothing but the work potential of energy. So energy is available in the form of heat and work, but its work potential is calculated based on the evaluation of the with respect to surroundings. So when you calculate the exergy, we have made a derivations, exergy at the initial state and exergy at final state. So delta X, exergy at the initial state is the difference between the given state of the system and the dead state. Exergy at the final state is also defined by the same manner. Now, in this particular questions, when you look for the lectures for this class, we have derived this particular expression, that is exergy of the system, which is given by three major terms. One is by virtue of internal energy, other is virtue of by the flow work between the system at the given state and its surroundings. And third part, this is the additional part. The third part, which is a loss, that loss part is given through an entropy. So that is the what we say destruction. So that is what we evaluate these particular problems. In particular, with respect to this query, the learner also wishes to know that the exergy of utilized work is system boundary surrounding is correct. But here, at this particular expression and this particular expression, which is in this case, they are more or less same, because the first term, which is n u1 minus u2, comes here. So that is u1 minus u0, because okay, in this case, your system initial state and final state, they are final state, and the dead state is fixed. So that is what the expression that comes from the internal energy part is associated here, and with respect to boundary work, that is boundary work, pressure, surrounding pressure, and volume difference, that comes here. And third part is the loss part. Normally, this comes from the Q, that is associated with respect to entropy of the systems. So this part refers to the exergy destruction due to the interactions. So whatever the learner is wishing to say, we have used the same expressions but in a different format. And derivation of this is also available in the book as well as in our lecture notes. The third question is basically the module number 3, lecture number 2, question 8 of assignment 5. So the question was asked that it seems some data is missing and you need to calculate the volume of the combustion chamber at the end of the combustion. So as far as the question is concerned, this is at the primitive stage where you are going to introduce the automobile the engines, nomenclatures, and its structure. At that point of time, we have not come across the combustion part yet. So the question of combustion at TTC, that means in degree of TTC, it will be more accurate. But however, for this problem, we don't require this data because we have not reached to that stage when we are looking at the problem in this assignment. So of course, when we go towards that, the data will be more precise and accordingly we can find out in a different expressions or philosophy. But however, with respect to the questions, I don't think there is any data is missing. One simple problem which is solved here, that is same question assignment from question number 8. So here the data which is given is the compression ratio, length of these things, and since it is a square engine, so a bore and strokes, bore diameter and stroke length is same. So you can get the volume that is displacement volume, and here it is a 4-cylinder, it is a 4-liter 5-cylinder capacity. So displacement volume will be 4 by 5 liter, and this for this displacement volume, and looking at V is equal to X, we can calculate the bore diameter, and since bore and it's a square engine, bore and stroke length will be same. So we also find this stroke length. So now we have the expression for compression ratio. So when you have the compression ratio, we find the displacement value complete and compression ratio. When we put this expression, we find this as a clearance. So when I say the volume of the combustion chamber at the end of combustion, which means that your combustion process is already over, entire charge is within the clearance volume, and the piston is about to expand. So that is nothing but your clearance volume where entire charge product is concentrated. The question was asked that we need to find what is the volume of this combustion chamber. So it is nothing but your clearance volume. So this is how the problem needs to be solved. And similar problem is also solved in the same lectures by looking at this particular diagram, that when the piston is at the TDC, just at the end of combustion, entire clearance volume is within this, entire charge is within this clearance. So this is all about my lectures or the doubts which is given here. Now, if there is any queries, I can get back to you. Dear learners, now there is no such queries. I sincerely appeal, in case you are unable to find this live session convenient, you can raise your queries in the discussion forum, and so that we can put them in the live session as an benchmark for the learning process to all of you. So we assume that there is no such queries, but however, I strongly suggest you write your queries in the discussion forum so that you can compile all these all these queries, and in the next live sessions we will try to put up the answers. And of course, these queries will in the discussion forum will be also addressed, and more clarifications, please join in the live sessions. Another point I would like to make is that those who are raising queries, please ensure that you appear in the live session so that you can put up your questions and your answers will be clarified. So with this, I conclude this live sessions.